Hi guys, my name is Rohan and I welcome back to my channel. In this video, I'll be explaining about the differences between SQL and NoSQL type of databases. Right, we have worked with several SQL databases earlier. I thought I'll introduce NoSQL also, as NoSQLs are getting more popular these days, and it has got a lot of flexibility and benefits when it comes to horizontal scalability and the performance and various factors. So I'm going to start this comparison video, and then we will take one of the NoSQL database. We'll run through some of the commands, and we will also do a hands-on on Talend to see how the data can be retrieved using NoSQL database. So let's get started here. So I'm going to start with the comparison first. The SQL is a type of relational, and NoSQL is non-relational, which means SQL is more appropriate for transactional based applications, whereas NoSQL is not that faster to keep up with a transactional system, right? So that is the very basic difference. I'm not going to add more here. And moving on, in SQL type of databases, there is a fixed schema. If a table has 5 columns, 10 columns, it's fixed for throughout the table. Whereas in NoSQL, you can have any number of columns for different records. So you can still create a table in NoSQL. In the first record, you can have 5 columns, and in the second records, you may have totally different 10 different columns. So that kind of dynamic schema is possible in NoSQL. And moving on, SQL type of databases store the data in the form of table, whereas NoSQL it also stores in a table, but in the data organization will be based on key value pair or tree structured or graph based structure, data organization, right? And moving on, SQL databases support vertical scaling, which means you can have any number of records, like million, 2 million, and things like that. You can scale only vertically, whereas NoSQL database you can scale horizontally as well. Even if you have multiple columns or attributes for a particular record, you can still scale horizontally and perform better in NoSQL. Whereas when you add more and more columns to a single SQL table, it's not going to perform better, right? You will start seeing performance issues and several challenges with horizontally scaling in SQL side, right? So and moving on, SQL supports ACID property, which means every transaction on the SQL type of database provides atomicity, consistency, isolation, and the durability, right? It's always in the ACID property. Whereas in NoSQL, it follows consistency, availability, and then the partition type of property. And the next comparison here is you can have any number of complex queries. You can have 10 different table joins with certain columns, right? There is a integer based keys, so you can write complex queries to perform any data analysis on the SQL. Whereas NoSQL is meant for simple retrieval of data. If you want to just retrieve the entire data set, that is very efficient. But when it comes to complex queries, joins, and multiple in operation, the NoSQL is not that preferred. But it supports retrieval of horizontal data as well. And the next comparison here is it is not suitable for hierarchical kind of data. What I mean here is SQL databases are not meant for something like a Facebook or having multiple connections. A friend of friends connection may have a number of friends or posts, right? So those type of hierarchical data are not properly suited for SQL type of database, whereas NoSQL supports hierarchical data as well. So the next difference here is it is more suited for transactional. Since it's relational database, it will always perform better on the transactional data. But NoSQL is suited for faster analysis. If you want to do some sort of data analysis for over a period of time and do some analytical processing, you can do it much better using NoSQL type of database. And the next difference is the SQL databases usually requires a lot of data modeling in the beginning itself because you need to define all the keys, table structure, and the foreign keys, and the data length, the data type, and all those things require a lot of modeling in SQL type of database. Whereas in NoSQL, it is very easy for developers. You can just keep adding whatever number of columns you want to add, and you can just scale it easily. So that is one of the major feature on NoSQL. And here are some of the examples: SQL Server, Oracle, MySQL, PostgreSQL. These are all type of an SQL database. And on the NoSQL, you have DynamoDB, HBase, Bigtable, MongoDB, CouchDB. These are all NoSQL type of databases. So for this video, I'll be making use of HBase because this is a standalone, and you can also spin up, the Hadoop cluster easily and then work this out. Because DynamoDB and Bigtable or Mongo, you need to have a lot of setup, and also it might cost you some money over there. So just for the sake of simplicity, I am taking HBase, NoSQL for this video. We'll also learn about HBase and we will do some hands-on using Talend as well. So let's get started on that. So currently HBase is an open source and it is licensed after the Apache Foundation, and it is a columnar storage. Unlike in any other relational system, the data is actually stored in the form of records, but here in HBase, the data is stored in the form of columns. So that is why it is column oriented solution, and it is distributed because it is sitting on top of HDFS, which has multiple data nodes and a master node, right? All the computation, data analysis, everything happens on the distributed system. So HBase is a NoSQL database, and it is not really RDBMS solution. So what do you mean by RDBMS? The features such as indexes, triggers, advanced query languages, analytical functions. So those are not part of HBase. So if it is not a database, then it is called as data store. So this is the right term for HBase. It is just a data store along with some regional servers and in-memory capabilities. It can perform really real-time big data application needs. So it was earlier it was called as Google Big Table. Afterwards, it was renamed as HBase. So HBase is faster, scalable, reliable, and also fault tolerant. This is mainly because of HDFS, ecosystem. It provides a number of nodes, so the processing becomes really faster at each and every node level. Scalable is because if your data needs or analysis requirement increases, you can easily extend your regional servers so that you can easily scale your cluster. So reliable and fault tolerant is because of the data redundancy. So the data is stored at multiple data nodes. Even if one of the node goes down, you still get your data from the remaining nodes. So that's why it is called reliable and also the fault tolerant. Moving on to the architecture. So client is a tool or some application, external application trying to access or perform any data analysis via HBase. So in our case, we'll be using Talend as our client, right? So from Talend, you directly connect to the Zookeeper. So when you create the connection in Talend, all we specify is the Zookeeper. So Zookeeper is a service which is responsible to track and keep track of health of the entire node. It's not just HDFS, it also perform various other operations. So Zookeeper actually initiates all the requests to HMaster. So HMaster is nothing but something called as a leader node, right? It's a leader wherein all the requests from the client is received by HMaster, and it will work with workers node. So here in this diagram, all the regional servers are nothing but worker nodes. So the actual computation, analysis, aggregation happens at this layer. And we have finally data storage layer, which is HDFS, right? So as soon as there is a request coming from a client system, the request is received at the master and compiled, and the instruction is sent to the available regional servers. So based on the capacity, based on the availability, HMaster will decide to which regional server the request needs to be sent, and that will perform the leader kind of a role in this entire architecture. So, um, HMaster is our leader, and the regional servers are the actual workers. So leader will always monitor for monitoring the worker nodes, and also assigning all the client request, and when that is done, it will also retrieve and then pass it back to the client application. So inside this regional servers, even though it is called as region, it is not really related to any location, right? It is just named as worker. No, instead of location or a region, it is termed as the worker nodes. Okay, so each worker node, it can be multiple based on the requirement. You can actually scale those and have any number of regional servers. This is based on the use case and the processing power that is required. You can extend it, right? This is how you can scale it. And each of the regional servers comes with various components. The top ones are actually the block cache and then memory store. So these components are actually helpful to retain some of the data analysis aggregation which is happening in the memory, and all the aggregation happens at this layer, and then pass it back to the regional server, and that's how the client request will be totally fulfilled. And last but not the least, in this HBase architecture, HDFS plays an important role of the data storage. We have seen this in our case of Hive also, right? HDFS will have the data nodes. That's where actually the data is stored, and we have a name node. Similarly, how we have HMaster and HBase. Under HDFS, you have name node that takes care of all the data nodes, right? So this is where your data is stored in a form of blocks, and based on the request that is received from the client, the data is retrieved from respective data nodes, and aggregation or analysis is done on the regional servers. I hope this is now clear. Let's move on and understand a few more concepts here. Here are some of the useful commands here. First one is the status. This is to provide the status of the HBase. For example, how many number of servers we have. Those type of information is provided by server command. And you can also find out the version of HBase. If you need any table reference commands, you can just type in table underscore help. It will give you respective keywords along with some of the help text. You can also pass a command who am I. This will return the user that it is currently executing. So moving on, HBase supports DDL, data definition languages, which is in relational terms. We create a table and alter a table, disabling, enabling, right, dropping. Those are all some of the DDL commands. Like how the data definition is available in other relational sources, like in case of MySQL. Those are similar here also. The HBase provides certain DDL commands here. So let's look at it. So create is the first command. These are also called as shell commands. create is used to create a particular table in HBase, right? In like how you have MySQL or Oracle, the same way you can even create a table in HDFS, sorry, HBase also. So that is done using create command. And we have a list command to list all the tables that are available in HBase. So disable is additional command which is not there in relational system. Directly we drop the table in case of MySQL or Oracle. But here in HBase, you will have to first disable the table and then you drop it. So that is the sequence. And there is a command is disabled to make sure to check if the particular table is disabled or enabled state. Right. Likewise, for the disable, we also have enable command. We have describe. This is the same command which we use in DBMS as well. So this shows the description of the table, like how many columns are there and what's the column level details are available in describe command. And if you want to alter command by adding a new column family or new column, you will be using the alter command. Using the exist, you can verify if a table exists or not, and drop command is used to drop the table from HBase. Right, there is a drop all also available, using which you can drop almost all the table. So this is all about the data definition language. Let's move on and find out what are the DML operations are permitted in HBase. Right, so DML commands are nothing but like adding a row, deleting a row, counting records. Right, like in RDBMS we have insert. Right, you have insert, update, delete, count. Right, you have many other manipulation language statements also. When it comes to HBase, these are the DML operations allowed in HBase. So first one is a put command, which is nothing but your insert in relational. Right, using put, you can add more and more rows for a particular table for a specified column. Since we are talking about columnar, we will have to always specify the column for a particular record, and you can insert data using the put command. Likewise, you have get command which fetches a content from a row or a cell. Delete command is used to delete a cell value, and you have a delete all to just delete all the cells in the given row. And you have a scan, which is nothing but a select statement, right? And you have a count using which you can count number of records, and also you can perform truncate operation on the HBase table. So these are all the DML operations permitted in HDFS, right? So moving on, we have got some shell commands as well. The prompt for HBase is always called HBase shell, right? So this is where you will be logging into your SSH, right? You will log into SSH and then go to this particular folder, right? Wherever your HBase is installed, you will have to go there and cd HBase. So that contains a bin folder. So this folder contains all the shell commands. So this is the prompt you will be getting when we get onto the shell. So let's get started with the actual hands-on, and then we will move on to verify how we can do this in Talend. Most of us are actually from a relational database background. One or the other database is already familiar to us. So I will just quickly run through this HBase shell commands, and we can perform the same operation inside Talend. So the first thing first, to create the table, this is the syntax: create table name and then the column family name. So here, this is the new concept here. It's called as column family name, which is nothing but if you have multiple fields for a customer field, let's say for example, you can categorize something like customer personal details, and department salary, you can call it as an official details, right? So those are categorized as column family. So likewise, you can create EMP table, right, having these two columns. Okay, so this is our uh, shell command to create a particular table. So once that is created, you can simply use describe space then the table name, right? You can perform count using a count command, count and then the table name, and you can specify if you want to read only like from 1000 cache, you can do that. Otherwise, this is optional part. This can get you the counts. In order to insert a data into a particular table, this is the put command syntax as well. EMP is our table name, and this is the row name. Row name and column value is something slightly different when it comes to relational insert statement. So every put statement should have the table name and then the row name and the column name and the column value. So this is how we are specifying the value 10 for this particular C1 column, right? So this is inserting one particular record. So if you want to do multiple record along with creation of the table, you can do so using create command followed by the put commands. Similarly, select star from employee table is translated as scan particular table name, right? And similarly, get command is used to get data from a table for a particular column. A column in HBase may be thousands of columns you may have for a particular table because it's a columnar storage. So in those scenario, you will need to retrieve data for a particular column, right? So for that reason, you'll be using um, get command. Similarly, you can truncate a table using truncate and the table name, and dropping the table is drop and then the table name. Right before you drop, you will have to disable the table and then drop the table. Right. So these are some of the syntaxes for creation. I'll try to put this in a description box below so that you can access these and perform your hands-on. So these should be done directly on the SSH, like how we have seen in the current window. So I'll once you log into the SSH, you should be seeing a prompt like this. So once you get this prompt, all you have to type in is HBase shell. So this will take you to the HBase shell, and you can input the commands over there. So if you go to Ambari, you should be able to see that service running under Ambari as HBase, right? So this shows whether my service is up and running or not, right? Yeah, so this is the HBase summary. So everything seems to be okay. And as we see, this is the shell, right? So once this is done, we can type in the command as list. This will list all the available tables in that particular HBase instance, right? You can even say scan from a particular table. We will have to always prefix with this single quote. So these are the data records available in this particular table, right? If you carefully notice, the way it is retrieving data is slightly different. Okay, so these are some of the columns. Category ID, category description is one of the columns in this particular table, right? So this is the reason we are not calling it as relational. It's not really stored in a record format, right? I hope this is all clear now. I'll move on to the talent part. I have already created this, the skeleton of the job so that we can save some time. So here you see this is the HBase connection. So as we discussed in our architecture, Talend is a client. So client connects directly to the zookeeper, right? So this is how we were discussing, right? So Talend connects to zookeeper, and that will enable us to access the regional servers and perform any data input output kind of operations, right? So I'm using pre-job to create the new connection and post-job to close the HBase connection. So this is how this is very simple. All you have to do is just provide the zookeeper and it will create the connection for you. So for the actual data transformation, I have used one of the Hive table as input. Okay, so these are the standard settings we have seen in our Hive as example, right? I'm reading a table called a category from Hive database, and then I'm loading into HBase. So when we pull this HBase output component, so here are some of the properties. So I'm trying to reuse the HBase connection here, and I'm providing the table name, and there is a way we can specify to drop the table if exist, or create a new table, create table if not exist. So there are several action on the table available, and we can use any one of those appropriate. And here one additional thing in HBase is that for every column we will have to specify the family name, right? So right now we are dealing with category table. So we have got ID, parent, and description. So we have given a family name, right? So this is mandatory. Without this, you will not be able to load any data into this particular table. Okay. So likewise, under advanced settings, you have an option. You can, put some family parameters. We will discuss in our upcoming advanced topic. But for now, in the basic settings, you will have to specify all the columns along with the family name, right? So once this is done, that's all. The data will be read from your source and then dumped into the target. So for the sake of easier display on the screen, I'm using the same table and I'm using HBase input component here, right? So it's the same table and same set of columns and the column family, right? Input and output components, they have exactly same settings to specify the table name and then the column name along with the family, right? Once this is done, all you have to do is just connect to tlog we'll print it as a table. So let's see how this works. So the job is now running. It has started processing the input records from Hive database, and then the table name is called category, right? We had four records that is now written into the target HBase, right? So we have successfully inserted four records into our target. So from we had already data available in this particular table. So 12 records are read and then printed on the console, right? So these are the column values that are stored in HBase and also retrieved. So this is the simple example. You can further extend it and try out with your own input and output operations. The same flow you can even connect it to t aggregate row, sort row, or do some pivoting. You can do a lot of operations directly in HBase. So this is exactly how you work with HBase in Talend.